Good evening, my dear students. Welcome to HashLearn Studios. My name is Dheeraj, your chemistry teacher for the day. And the topic under discussion is stability, importance, and application of coordination compounds. This is part of the lecture series JEE and NEET. So don't forget to subscribe to HashLearn to make sure that your JEE and NEET learning process goes very smoothly. Proceeding, the recap of the previous class was we looked at bonding in metal carbonyls, some MCQ aspect of metal carbonyl bonding, and apart from that we looked at various other problems as well. And to talk about the CPP question that I had picked up for you guys from the list of questions that I had given to you, the octahedral complex CONH3 4 times Br exhibits isomerism. So what kind of isomerism? What kind of isomerism is exhibited by this compound? You have straightforwardly given that we can expect it to exhibit geometrical as well as ionization isomerism, since 4 NH3 groups are present which can show cis and trans forms, and the others give ionization isomerism. So the details are available. Hope you guys have followed, and quite an important question as well pertaining to isomerism. Like we said, today's goal would be to look at stability, importance, and application of coordination compounds, and also to look at those aspects which we have looked at so far in the previous classes, as well as since this is the last class to do with coordination compound, I would want you to give emphasis to everything that we have covered so far, along with the major emphasis for today's concepts. So the next slide that you will be seeing, guys, is the first question for the day. And before I proceed, we have Sakshi Pandey and Pooja joining us. A very warm welcome to the webinar, guys, and a great good evening as well. So let us quickly move. The next slide that you'll be seeing is the first question for the day. So have a look at this. Which of the following paramagnetic complexes with +2 oxidation state of central metal shows geometrical isomerism? So I've picked up the first question for the day from isomerism since it's important. So which of the following paramagnetic complexes with +2 oxidation state of central atom shows geometrical isomerism? That's the question for you guys. It's NiEn3Cl2. En stands for ethylene diamine, didentate ligand, and CrEn twice, NO2 twice, nitrito. PTNH3 4 times H2O twice, Cl2, and CONH3 4 times H2O twice, Cl2. Which one is going to be the probable answer? The clock master says time's up. I'll give you a couple of seconds, guys. Think over which of the following paramagnetic complexes with +2 oxidation state of the central metal atom shows geometrical isomerism. So you have to think. Sakshi says it's 1B. Let me tell you, I think I've given it to you before also. Pooja says it's 1A. I've given it to you before also, guys. Molecule of this format, Ma4B2, gives geometrical isomerism. So you have to just check for which is it or which is of this sort. If you check, it is this. So 4 and 2. So it is this. So just try to understand that if you recall, I had given you around 4 or 5 different types of molecular formulae which will exhibit geometrical isomerism. One of it is this. So I would want you guys to always pay attention to those small details which I give you, so that you will remember and answer questions on a longer run. So it is Ma4B2 type. Ma4B2 type is this, and you need to also understand that amines charge is 0. It's a neutral ligand. Aqueous charge is also 0, water, which is a neutral ligand, and therefore if it is Cl2, it means the charge is -2. Therefore the charge on this is +2. Since this is 0, cobalt's charge has to be +2. So that is the answer. And then Sakshi says she likes my teaching style. Thank you so much, Sakshi. Students like you make teachers like us. So it is never the inverse. It's always students making teachers. So if you feel that you've liked my teaching, it is because I've got students like you. Hope you've liked it. Thank you. And Pooja says it's B, guys. I've corrected the answer for you guys. This is the right answer. Please pay attention to it and let me know if I can help you in any other way pertaining to isomerism. Now moving ahead, lead poisoning in the body can be removed by. All this comes as application and uses of coordination compounds. So lead poisoning in the body can be removed by. So think, is it EDTA in the form of calcium dihydrogen salt, cis-platin, Zeise salt, and DMG. DMG stands for dimethyl glycoxime. So EDTA in the form of calcium dihydrogen salt, cis-platin, Zeise salt, and DMG. Which one is it? Quickly. This is your application aspect. These are the factual questions which you have to remember, which we will not be able to give you reasons because lead poisoning in body can be removed by. There's no really much logic that you would study as 12th, 11th and 12th students. So you should know EDTA in the form of this cis-platin, Zeise salt, and DMG. So Pooja says it's option A. Let's wait for Sakshi also. Both of them say it's A. Right, guys. Option A is the right answer. Let me tell you. Lead poisoning, that is lead in the human body, will be present in the +2 oxidation state. It is going to combine with EDTA. You should know that EDTA is a hexadentate ligand and EDTA is ethylene diamine tetraacetate. Therefore, the charge on this is going to be -4. The tetraacetate, the 4 acetates are going to have -4 charge, and when they combine, you will have Pb EDTA 2 minus. And the best part is it is a soluble complex, hence it gets digested out of the system, so it gets excreted out of the system, I must say. So since it's a soluble complex, so that helps in removing the lead poisoning in the body. So cis-platin, I'll add a little information to all of these. What is cis-platin? Cis-platin is again a compound used to treat cancer. So what is cis-platin? Cis-platin is a compound of platinum, amine, and chlorine. So it's diamine, dichlorido, platinum. And what is Zeise salt? Zeise salt is, it's a salt of potassium, platinum, and chlorine. So it's potassium trichlorido platinate. So that is Zeise salt. DMG. DMG stands for dimethyl glycoxime. Dimethyl glycoxime. And the formula, I can give you the formula. It's a little complex, but that's okay. You try to remember. N double bond C CH3 double bond N OH. This is dimethyl glycoxime. This is just to throw a little light on the other options that you have, but the answer is EDTA in the form of calcium dihydrogen salt. Moving ahead, guys, to the third problem. Which of the following is placed after ammonia ligand in spectrochemical series? So what is spectrochemical series? Spectrochemical series is the arrangement of ligands in the increasing order of their capacity to split the d orbitals. You will see this in crystal field splitting theory. In crystal field splitting theory, as ligands approach the central metal atom, the ligands degenerate d orbitals will split. So how much will it split? That depends on the approaching ligands. So based on the splitting effect of ligands, I've arranged the ligands, and that series will be called as spectrochemical series. You just have spectrochemical in this and an electrochemical series in electrochemistry. So these are the two series that you have to remember. Quickly give us the answer. Cyanide, Cn minus, oxalate, C2O42 minus, C2O42 plus, and none of these. Which one is going to be the answer? Which of the following is placed after ammonia in this spectrochemical series? It's a little difficult to remember the entire series, but mind you, you can have questions like these as well. Therefore, it will force you to remember the species in the series. Pooja says A. Sakshi, give us the answer quickly. Sakshi says it's C. No, guys, it's option B, because it is cyanide present first, then it is BIPY stands for biphenyls, and then it is ethylene diamine, I must say, ethylene diamine, then it is NH3 then it is oxalate. Therefore, you'll find oxalate after ammonia. So questions like these can be predicted based on our knowledge of spectrochemical. See these guys. Moving ahead to the fourth problem. Read the problem very carefully. A complex X with empirical formula PtCl2 2NH3 observed to show the conductivity but does not produce AgCl when treated with AgNO3. There is no geometrical isomers for X. Select the correct answer or the statement for X. It is paramagnetic. Formula of X is PtNH3 twice Cl2. Complex has oxidation number of Pt equal to +4. Name of the complex is tetramine platinum 2 tetrachloridoplatinate. Take a minute, try to understand the importance of the question as well as the question to see how it goes. Clockmaster says time's up, but take your time, guys. Have a detailed look at the question once. Yes, paramagnetic formula, complex have oxidation number +4. Which one has to be the right answer according to your knowledge? Sakshi says it is D. Let's wait for Pooja's answer as well, and I must say the answer is right. Name of the complex is tetramine platinum 2 tetrachloridoplatinate. This has to be the right answer. So tetramine platinum 2 tetrachloridoplatinate. So a complex with empirical formula this observed to show the conductivity but does not produce AgCl. If it does not produce AgCl, it means there are no ions present outside the coordination sphere, because anything present outside the square brackets, that's the coordination sphere, will produce molecules. But if they say it does not produce AgCl, which means nothing is present outside. So what is going to happen? Everything is going to be present within the square brackets. If everything is present within the square brackets, it has to be in the form of a cationic complex and an anionic complex. Therefore, tetramine platinum. Tetramine platinum is Pt NH3 4 times, and platinum's general charge is +2. This has to be counteracted by tetrachloridoplatinate. So Pt Cl 4 times -2. So this is the structure. So this information, the conductivity does not produce AgCl, means nothing is present outside the square bracket. So that makes our work a little easier. So D is the right answer. Good. The next slide that you would be seeing is the previous classes contest question. The question is the complex PtNH36Cl4 furnishes how many ions? We were just talking about it in the previous question. Whatever is present outside the square brackets, which is the ionization sphere, coordination sphere, it will convert itself into ion. So this is going to break itself into Pt NH3 6 times 4 plus 4, and you will have 4 Cl minus. So that is 4 plus 1, 5 ions. So the right answer was given by Peru. Unfortunately, Peru has not joined us today, but the right answer was given by Peru. He has won himself an atom session. So he has won himself an atom session, which gives him exclusive right to get either a concept or a critical question to be answered by our in-house experts within 20 minutes of posting the question. So the next slide that you guys would be seeing is the current classes contest question. 60 seconds timer, guys. Go ahead and make sure you win yourself. Okay, hope you guys have given us the answer. There was a slight delay, guys, due to a technical glitch from our end. So we are back, and Pooja had asked both. Sakshi gave us the answer. Hope Pooja has also given us the answer. Pooja has asked why 5 is the answer in the previous question pertaining to the fifth question. That's the fourth question. So I hope we will try to move back a little. We'll move back a little, and we will look at this question. Pooja, you need to understand that whatever is present inside the square bracket will not break down into ions. So this entire thing will remain as one species, one ion, and chlorine. And what is the normal charge on chlorine? The normal charge on chlorine is -1, which means the chlorine, there are 4 chlorines in number, so 4 chlorines will make it -4, and we give this atom or ions that is present outside a specific name. We will call it as counter ions, because their work is to counter the charges on the coordination sphere that we have. So if it is -4, it means that the charge on the coordination compound is +4. So this will break into +4, one ion, and all of these Cl4s will break into 4 chlorides. Therefore it is 1 + 4, 5. So hope you guys have understood this. Moving ahead, try to quickly answer this question. So we have a good number of questions packed, guys, so let's pace it up a little. For an octahedral complex, which of the following d orbital configuration will give maximum CFSE? CFSE stands for crystal field stabilization energy. CFSE stands for crystal field stabilization energy. So quickly have a look at it. For an it's an octahedral complex with 6 bonds. So which of the following d-electron configuration will give maximum CFSE? So what is it going to be? Quickly guys, time's up. Let me know your answers. Yes, high spin d6, low spin d5, low spin d4, and high spin d7. Which one is it? We will take case by case. High spin d6, you need to understand that if I have a degenerate orbital, so the d block has degenerate orbitals, as the ligand approaches, the orbital is going to split into 2 levels. One with 3 orbitals, the other one is 2 orbital. This 3 orbital will be called as T2G, this 2 orbital will be called as EG. So when they say D6, high spin D6, they're talking about a CFSE energy. So the difference in the energy between the two is considered as 10 dq. So CFSE energy in case of 6 electrons is plus 0.6 into 2 minus 0.4 into 4. So this is equal to minus 0.4 delta naught. If you're wondering what delta naught is, the energy gap between the two layers are called as delta naught. If you look at option B, CFSC, it is plus 0.6 into 0.0, that is the no electron in the high spin, plus 0.4 into 5, which makes it minus 1.6 delta naught. Third one, plus 0.6 into 2 minus 0.4 into 5 delta naught, which makes it minus 0.8 delta naught. So if you have a look at it, you will understand that option B is the answer because it has the maximum delta naught, that is 0 minus 1.6 delta naught value. So it has the highest CFSE value. So option B. So Sakshi says it's A, Pooja says it, Sakshi says it's A, C, Pooja says it's A. But guys, hope you guys have understood, depends on the electronic distribution. Moving to the sixth problem. NiCN4 4- is isostructural with you don't need 45 seconds to answer questions like these, so move on really fast. NiCN4 4 minus is isostructural with, you have XCF4, SiF4, SF4 and a complex tetramine platinum chloride. So work on it really fast. So what is it going to be? You don't need too much time is what I said. Give us the answer guys, really fast. NiCN4 4 minus is isostructural with, if you have a look at it, the hybridization of NiCN4 minus is sp3. It is sp3 hybridization. Therefore, you'll have to look at the molecule which will show sp3 hybridization. That is SF4. Whenever they talk about structure, mind you guys, you have to know hybridization. With hybridization, our work becomes very easier. So there are 4 bonds. 4 cyanide for nickel, it is sp3, and in case of SF4 also it is the same thing. So it has to be option C, which is SF4 because of hybridization. So we have another student joining us, Considerate Cat. Let us know if we can call you by your name, which makes our communication a little more easier. So this name sounds a little peculiar. Moving ahead guys. Which d orbital of the metal in FeCO5 times? It is a carbonyl complex of iron. Which d orbital of the metal in FeCO5 times is involved in hybridization? Okay, so Sakshi has asked us to repeat the question. We will do that, Sakshi. Give us a minute. Which d orbital of the metal in FeCO5 times is involved in hybridization? Really fast. So how many ligands? 5 ligands. Therefore, what will be the hybridization? The hybridization will be sp3d. When the hybridization is sp3d, which orbital gets involved? So 5 ligands. 5 ligands means hybridization will be sp3d. 1 plus 3 4 plus 1 5. So when you have this, which d orbital will take part in this hybridization? You need to always remember that if one d is involved, it is dz square. So dz square orbital will take part in hybridization. I had asked you about this in the previous chapter as well. So your work is to create a list. When there is 4 ligands involved, sp3, or when there are 5 ligands involved, sp3d or sp3d2 or sp3d3, which of the d orbitals will be involved in hybridization? You have to create a note. So you have to remember which orbitals are involved. Only then you can answer some very simple questions like these. It will not take too much time for us. It is merely making note of the orbitals involved in the hybridization, because those are the ones which will take part in bond formation as well. So that work you have to do. I've told you guys before also. So I'm hoping that you will manage this really fast. So keep that thing in mind guys. 8th question. Consider the following reaction. MGLY. GLY stands for glycine. It's an amino acid. MGLY and EN stands for ethylene diamine. If reactant has no stereoisomer but product exists in 2 stereoisomeric form, then hybridization of the metal in the product is the question. So you guys have given us the answer. Sakshi says it is A. Okay, Clockmaster says another couple of seconds left. Have a detailed look at the question guys. Have a detailed look at the question. Metal, glycine, EN and MGLY 2 times. If reactant has no stereoisomer but product exists in 2 stereoisomeric form, then hybridization of the metal M in the product is. Take a minute. This question is going to need a little thorough understanding. So try to solve this. We will look at this question tomorrow. Try to solve this, guys. I'll give you a clue. You don't have to give me the answer. Take a detailed look at this question. Try to draw the involved stereoisomers and then try to give me the answer. So try to solve this. We will have a look at this question in the next class of mine, because stereoisomerism and stereoisomerism, especially in coordination compound, is an important place where there can be a there can be a lot of scope for questions. So have a detailed look at this. I'll acknowledge your answers. If there are questions, you guys are right. Both of you have actually given me the right answer, but I want you to have a detailed look at this question. We will worry about it in the next class when we are taking up the next session. Yeah. So moving ahead to the 9th question. Select the correct statements about PtCl4 4NH3 complex salt. All the chlorides are bonded by primary valencies. All the chlorides are bonded by secondary valencies. All the NH3 are bonded by secondary valency. Half of the chlorides are bonded with secondary valency. Which one do you think is the right answer? Should not take us too much time. Should be a simple question to answer. PtCl4 4NH3. So just think. Like I said, shouldn't take you 45 seconds as well. PtCl4 4NH3. What should it be? Pt NH3 4 times Cl2. The general charge on platinum is +4 oxidation number, and in this case it is NH3 4 times Cl2, and to balance the charge you will have Cl2 outside. So if you write the structure, you will be able to instantaneously give us the answer. All the chlorides are bonded by secondary valencies, so that has to be the answer. All the valencies are bonded by secondary valency. Yeah, no, all the chlorides are not bonded by primary valencies. All the chlorides are bonded by secondary valencies. So this is just to merely balance. Okay, so if you want, you can write this as well. So Pt NH3 4 times Cl4, it can be this as well. Okay, moving ahead. Which of the following cobalt complex is paramagnetic and a high spin complex? Which of the following cobalt complex is paramagnetic high spin complex? Have a detailed look. CO H2O 6 times 3 minus, and CO C2O4 thrice 2 minus, COCH thick CN6 3 minus, and none of these. So think, guys, think. Which of the following cobalt complex is paramagnetic? Paramagnetic has to have unpaired electrons. High spin, you know what high spin means. So try to answer this fast. Shouldn't take us too much time. Sakshi says it's 10B. Okay. So now what decides? Pooja says it's 10C. Let me tell you. What decides whether it is paramagnetic or diamagnetic? Unpaired electrons. What decides whether it is high spin or low spin complex? Guys, it's really simple. If the energy difference between the two is really low, electrons can get promoted. If the energy difference between the two levels are really high, the promotion of electrons will not take place. What decides the energy gap between the two levels? It is the ligands. Now if you observe, let it be water, let it be oxalate, and let it be cyanide. All of these are strong ligands. Since they are strong ligands, splitting is more. Splitting is more. If splitting is more, the compound has to be low spin. If splitting is more, compound has to be low spin. So the answer is none of these. It just depends on the strength of the ligands. If the ligand strength is weak, then I can have high spin complexes. If the ligand strength is high, or if the splitting is high, I should be having low spin complexes. So option is D. I hope you guys have understood. Try to always approach the problem based on how I teach you, because that's the easiest way out of it. So Sakshi and Pooja, even though you've given us the wrong answer, that's okay, but I hope you guys have understood the approach. So let us move to the next question. This is again an analytical type question. Try to answer this analytical type solving question. 0.001 mole of CONH3 5 times SO4 NO3 was passed through cation exchanger, and the acid coming out of it required 20 ml of 0.1 molar NaOH for neutralization. Hence the complex is. So the question is a little tricky, definitely very important. So it involves stoichiometry with coordination compound. So have a detailed look at the question. Take a couple of more seconds, no worries, but have a detailed look at the question. So the coordination compound was passed through the cation exchanger, and the acid coming out of it required 20 ml of 0.1 molar NaOH for neutralization. So have a look at it. Pooja says it is C. Let us wait for Sakshi and then we'll proceed. Meanwhile, Sakshi also says it is C. Let us see now. Have a detailed look at it. 0.001 mole of CO was passed through cation exchange. Acid coming out required 20 ml of 0.1 molar NaOH. Therefore, millimoles of acid. How much of base is needed? 20 ml and 0.1 molar, which means that much of acid is also needed. Therefore, millimoles of acid is equal to 20 into 0.1, which is equal to 2 millimoles. So 2 millimoles of acid is coming out when you pass 0.01 mole, which means that 0.001 mole of complex is neutralizing 0.002 moles of base, because we have calculated, no? What is the millimoles of acid? Millimoles of acid is equal to millimoles of base, which is neutralizing. So base is 20 into 0.1, which is 2. Therefore, the acid is also same, base is also same. So 0.001 mole of complex is neutralizing 0.002 moles of the base. So it means that the acid that is coming out, should be basic. This is the logic, guys. Hope you understand. Pooja says we are giving answers earlier. Looks like the regular network issue, not really the network issue. There's a little time lapse, Pooja. So no worries. But I hope you're solving the problem from your end really fast. So that matters. And we have Yogesh joining us. Yogesh, good evening. You've joined us a little late, Yogesh. No worries. But then you have another session of mine starting shortly. So make sure you join that session really fast. That session starts by 7:15. So no worries. We just have a couple of more questions packed for you. So have a look at it. So this is the answer, guys. 20 moles needs 20 ml of 0.1 molar NaOH needs 2 millimoles of the acid, which means that 0.001 mole of the complex is neutralizing 0.002 moles of the base, which means the acid coming out should be basic, because 0.001 cannot neutralize 0.002. If it is neutralizing, it means this as well as this is same. What is this? A base. Therefore, if it is neutralizing this, this also has to be basic in nature. Hence, what would be the right answer? Hence, the right answer in this case would be option B. Why am I telling you it is option B? Because CO NH3 5 times NO3 SO4 gives CO NH3 5 times NO3 twice, that's plus 2 plus SO4 2 minus. The complex is option B. So have a detailed look. We have Jayant also joining us. Good evening, Jayant. Moving on a little ahead, guys. This is a little critical type of problem wherein we have tried to incorporate calculations into coordination compound. But you have to be in a position to answer questions like these. This is a proper JEE mains and a little overlap JEE advanced version type question. So hope you guys have understood. If not, ask. Or else after the class is done, have a detailed look at it once again so that it makes better sense to you. Okay. So moving ahead, the 12th problem. In an octahedral crystal field, the T2G orbitals are. So we just looked at crystal field splitting. Crystal field splitting is the 5 degenerate orbitals are broken into 2 levels, T2G level and EG level. And what is the difference between the T2G level and the EG level is the question that is asked. So have a look at it. Raised in energy by 0.4 delta naught, lowered in energy by 0.4 delta naught, raised in energy by 0.6 delta naught, lowered in energy by 0.6 delta naught. Sakshi, I advise you to have a look at the solution once again, and if there are more queries pending, we will take it up. So have a detailed look at the question once again. So Sakshi had a small doubt pertaining to the previous question, so I was addressing that. So octahedral complex T2G levels are simple. It is lowered by 0.4 delta naught. Guys, T2G level, T2G is below, EG is above. So if this is 10 dq delta naught, if you take the mean, this is 0.4 and this is 0.6. 0.4 delta naught, this is 0.6 delta naught. So it is lowered in energy by 0.4 delta naught. So T2G is below, EG is above. Yogesh and Sakshi, I hope you guys have understood. I think you have looked at the tetrahedral crystal field. In tetrahedral crystal field, it is reverse. Here it is T2G and EG. In tetrahedral crystal field, it will be reverse. It will be T2G above and EG below. So don't get confused. This is for tetrahedral. But for octahedral, this is how it is. Hence, option B is the answer. Moving ahead to the 13th problem, we just have another couple of problems packed for you. Pi bonding is not involved in. You have ferrocene, dibenzene, chromium, Zeise salt, Grignard's reagent. So this is fairly simple. We have looked at organic chemistry. So if you know that, if you know the formula involved, Zeise salt I've told you, dibenzene, chromium is not a big deal. Ferrocene is Fe carbonyl 9 times. So Grignard's reagent is the last option. Which one is going to give the right answer? Really fast. Shouldn't take us so much time. Quickly, guys, quickly. Problem number 13. Pi bonding is not involved in. Yes. Sakshi says A. No, Sakshi, ferrocene is a compound of Fe and CO, carbon monoxide or carbonyl. Therefore, it will involve pi bond. Dibenzene, benzene has pi bond. Zeise salt is again a platinum based compound which I gave you initially, which will include pi bonding. The only answer is Grignard's reagent, because Grignard's reagent is R MgX. Therefore, there is no pi bonding involved here. Hence, Grignard's reagent is the answer. Ferrocene I don't know, you guys, maybe you guys have you are confused with ferrocin, but the answer is Grignard's reagent, which is just RMGX. Where is the pi bonding coming from? Pi bonding means we are talking about the unsaturated compound, double and triple bond. So Grignard's reagent is the answer. So moving to 14th question. 14th question, you should be able to give me the right answer. I've made sure that the question is based on nomenclature so that we end it on a very high note. So just a couple of questions left. One more question after this. We'll be able to very successfully wind up coordination compounds. Have a look at it. Might look a little lengthy molecular wise, but quite an important question. You have potassium, chromium, cyanide, oxygen, O2, O2 inside the brackets, and NH2. What does this indicate? So what is it? This is amine, this is oxygen, and if it is inside square brackets, it means it is peroxy. This is cyanide. So what is it going to be in the alphabetical order? In the alphabetical order, quickly. Potassium, amine, this one, cyan, that is alphabetical order, dicyano, dioxo, peroxo, chromate, 6. Therefore it is potassium, amine, dicyano, dioxo, peroxochromate. Dioxo because there are 2 oxygens involved here, and there is whatever is inside the square brackets indicated is peroxo. So it is peroxy linkage peroxochromate 6. So it is option A. So let us quickly summarize today's class, guys. We had looked at stability, importance, application. Stability was less, but the application and importance of coordination compound was looked at in today's class. Like I said, I made it a point to include isomerism, bonding, nomenclature, and other aspects of coordination compound. And we have looked at around 14 questions. Another session of mine is starting shortly. It is at 8:15, and I'm really glad that the participation was good, and we are ending coordination compounds lecture on a very high note. I must definitely appreciate all of you to wholeheartedly try all of these questions which were assigned to you. And in case you have liked the class, please go ahead and share the class, subscribe to HashLearn, and students who have subscribed to HashLearn, you will have your CPP unlocked. You can have a look at the questions that we have assigned to you as homework. It is easy to solve the questions within the heat of the moment, and people who have not subscribed to HashLearn or CPP, you're just a click away. And CPP doesn't just give you access to the questions that we pick for you guys, but it also gives you access to 24/7 one-on-one doubt solving session, practice questions, tests from some of the best-selling books, and also the video classes needed to understand these questions in a much informative manner. So looking for your participation again in the next class, which is starting shortly. Till then, it's Dheeraj signing off. Bye guys.